Hi everybody. In this lesson we're going to be learning how to calculate the mechanical advantage of bolts and threaded rods. Bolts are nothing more than pieces of iron with threads on them, and you need to understand how many threads are on the bolt so that you can calculate mechanical advantage. What we have to do here is calculate the ideal mechanical advantage of a 1/4 NC bolt being turned by an 8-inch wrench. So we know that IMA in levers and all of the other mechanisms that we've been dealing with is a measurement of the distance of effort divided by the distance of resistance. So we've got to be able to come up with a formula that will allow us to figure out what the distance of resistance and the distance of effort are in a bolt calculation. So I've made a little diagram here. The first one is a wrench, and the wrench is on a bolt. A lot of bolts are either hex heads or square heads. So we've got a crescent wrench here, and the force of effort is being applied to the wrench and spinning it in a clockwise motion. So what we're trying to measure is how far does this wrench handle go around the center of the bolt. So the distance of effort in this case is how far are we spinning the bolt head to get a measurement. Then the second thing we need to know is D of R. So in D of R, what we're trying to do is we're trying to calculate if this is 1 inch here on the bolt. Here's a diagram of the side profile of a bolt. And if this is 1 inch from here to here and it has 20 threads in it, if this wrench turns it around one complete circle, then how far down is it going to go into the material that you're trying to turn it into? So a bolt that is a 20 threads in 1 inch will, in one revolution, go down into the material 1/20th of an inch. So if we know these two things, the circumference of this circle and the distance that the bolt's going to go down, we'll be able to figure out what our mechanical advantage is. So I've rewritten our formula for IMA. Instead of saying D of E over D of R, now IMA is equal to C over P. C being the circumference of the circle that the wrench makes, P being the pitch or the distance that the bolt goes down into the material. So in order to calculate what C is, what the D of E is in this calculation, we need to know what the circumference is. So what we've got to do is figure out 2 pi, pretend that's a pi, I couldn't find the symbol, 2 pi times R. R being the radius, and the radius being the 8-inch wrench. So 8 inches is our measurement there. And then C over P, P being the pitch, so we have 1 over 20. So in this calculation we can reconfigure this and plug in some numbers. So it's easiest if you turn both the top and bottom into decimals instead of fractions. So we have 2 times 3.14 times 8 equals 50.24 inches divided by 0.05 inches, because this is a measurement of 1/20th of an inch. So now we just do the math and we come out with 1004.8. And these are factoring out, inches and inches factor out, so it's 1004.8 to 1 as our mechanical advantage of our bolt. So I hope this has helped you to better understand the mechanical advantages of the bolt. Now if you notice here, by calculating this, you have figured out what D of E is and what D of R is. So whatever the answer is right here, you can use to calculate D of E and D of R in the next formula for figuring out AMA. So good luck with that, and watch the next video.